Open source code. How often do you use it in your production code? Or should I ask, how often are you aware of using it in your production code? Because even if you are not explicitly using it, the libraries or frameworks you use might be dependent on other open source code. What if any of these has a vulnerability? How would it affect your code? Would that mean loss to your businesses? As developers, how do you find and fix these and when? During development, testing, integration, or other? I know these are a lot of questions, but don't worry. Our speakers today are experts on this topic, and they'll answer all these questions and help you use open source with confidence. Hi, everyone. Thanks for joining in for another episode of IntelliJ IDEA livestream. I'm your host, Mala Gupta, and today I'm pleased to add two amazing speakers, Or and Guy. So we have Guy and Or, where are you? Yes. Thank you so much for accepting the invitation. It's a pleasure to have you present with us today.
Thank you very much, Mala. We're very excited to be here. Thank you for hosting us.
Thank you.
And let me mention that it is interesting how both Or and Guy have been passionate about security issues, and it reflects in how they started working with it, or should I say, when. Or started his cybersecurity journey when he was only 15 and found his first cross site scripting vulnerability. That is a tongue twister for me. And now Or has been in cybersecurity for the past 13 years as a passionate developer and a lead. And there's something else that Or likes, baking challah bread. Did I pronounce that right?
Yes, you
Yeah.
did.
Okay. And cooking other traditional dishes. And I guess probably we'll host another session to discuss about the security issues with those tasks and how to address them. And Guy not only believes in secure software, but also his personal physical security, and he practices jujitsu, which is a Japanese system of unarmed combat and physical training. And he's now a research lead with Checkmarx and works across a variety of security fields. So, Guy, did working as a professional with security inspire you to work with jiu-jitsu, or was it the other way around?
Both, I guess. I'm interested in all security in general.
That's great. That's a holistic approach to looking at things.
Exactly.
Yes. And before I let our amazing speakers take the center stage, let me share some quick housekeeping details. Everyone who's watching, please use the YouTube chat to post your questions. Yaroslav, another security expert from JetBrains, Ida, and I from JetBrains team will answer your questions as you post them. And our speakers will answer your questions towards the end of the session. The session is being recorded and will be hosted on IntelliJ IDEA's YouTube channel and also JetBrains Twitch channel. So if you haven't already subscribed to our channel, now is the time to do so. And if you like today's session, which I am sure you will, please like the video and subscribe to, as I said, our channel so you don't miss similar content. Or, and Guy, I will let you take the stage now, adding your screen, which is already here. Have fun.
Thank you again, Mala, and welcome. And thank you, everyone, for joining our web stream today about open source risks and how you can tackle them with your IDE. This stream today is for developers that want to take their first step in open source security. But if you have already have some sort of experience with open source security, or if you have worked with some SCA products in the past, feel free to check out some advanced materials we have on our blog post website, or just stick around to learn more about our capabilities inside the IntelliJ IDE, or learn about supply chain. So as Mala said, my name is Or. I'm leading the SCA product unit in Checkmarx. SCA stands for Software Composition Analysis, the industry name for products that secure the open source ecosystem you're using in your application and container environment. And here with me today, Guy.
Hi, everyone. Thank you, Or. I'm Guy, research lead from Checkmarx, and I'm pleased to be here today. Thank you.
And as we said, we work in Checkmarx. Checkmarx is application security company. If you're not familiar with it, we help developer and organization deliver their code and applications with high security standards while integrating seamlessly into their development process. Our portfolio is combined of multiple products sit over one platform that helps secure your proprietary code, container environment, supply chain, infrastructure as code, and of course, the open source dependencies you consume. And our agenda for today will be mostly, hopefully, demos and hands-on stuff. But we'll start with just to cover about, why open source risk is important. Then we'll show you some live exploit of open source vulnerability. Then we'll show a quick overview of the Checkmarx capabilities inside IntelliJ IDEA. Then we'll show you how to fix your first CVE. Followed by that, we'll talk about some prioritization capabilities and how we can triage vulnerabilities. And we'll wrap it with some talks about other open source risks that can be found out there. So let's start. So why open source risks is even important? So as probably all of you know, right, open source is everywhere and open source is great, right? As developers, we rely heavily on open source to move fast, stay innovative, focus on business functionality, and develop our features. And to be honest, open source is pretty awesome, and you can find some really cool open source projects out there on GitHub, and just keep all the latest and greatest in your code. But, and there is always a but, using open source component might introduce some risk into your application. It could be vulnerabilities, operational risk, legal issues, or supply chain attacks. And of course, the more you use open source, the more exposure you can get, not only by the dependencies you use or explicitly use, but by dependencies these dependencies use, transitive dependencies. And these dependencies could use more dependencies. And one of them could be vulnerable or exposed to supply chain attack. And this is what brings us here today, to talk to you about the Checkmarx capabilities inside IntelliJ IDE, available, by the way, for free in all Ultimate IntelliJ versions, I think starting the latest one. And when we originally partnered with JetBrains, right, first, it made a lot of sense to us to partner, right? First, because of the Checkmarx being securing developers and developers' code. And JetBrains, of course, provides the best ecosystem for development out there. But there was one thing that really resonated with us, which is the Checkmarx shift-left approach. So what is shift-left approach?
Well, shift left is a term that gathers a lot of attention in the recent years, and it makes a lot of sense, and let's see why. Generally speaking, the software development process phases looks like this. And traditionally, the security testing and all security concerns were addressed around the testing phase, with pen testers performing their auditing in staging environment and sometimes even in production environment post the deploy phase. With automated security testing tools, we were able to move more significant parts to the security testing, of the security testing to the test phase. But shifting left generally, it means moving the security testing earlier in the development process. And this is great for a few reasons. Detecting vulnerabilities with pen testing techniques in production environment means, of course, that you were exposed to such vulnerabilities for a while. But even detecting the vulnerabilities with automated tools during the testing phase causes effort of fixing those vulnerabilities, rebuilding the code again, and running all the tests before we can finally release. Our partnership with JetBrains allows us to push the security testing even more left to the code phase, detecting those security issues right when we still coding and preserve this exposure and hassle. So the bottom line is, the sooner we detect the vulnerabilities, the better. We're less exposed to exploitation, and the fix would be easier.
All right, so less hustle and less exposure. Sounds good to me. And let's see how it looks like. And as we said, we'll start with a live exploitation of an open source vulnerability. And what better way to demo how open source vulnerability can get critical than to talk about the notorious Log4Shell. As probably most of you Java developers, you are using some sort of logging library. And as I said, if you are using Java, you probably use Log4j, which is the most popular logging library for Java. And as probably most of you also heard, late last year, a critical vulnerability found in this Log4j library. This vulnerability, remote code execution, which essentially allowed attacker to exploit and run anything on the compromised or exposed machine and do anything they want in there. This vulnerability was widely spread and widely used out there. And probably if you're a Java developer, you probably heard about it. You probably had to fix it. And this probably was the first, maybe for some of you, the first engagement with open source vulnerability. So let's see how it looks like.
Great. So I will demonstrate you an application that we pre-made before this webinar. This is a web application that interacts with Java web application that is, of course, using the notorious log4j of an unpatched version, of course. And in this session, we will not dive into too many details of the log4shell vulnerability. We'll not get detailed information about how it is being exploited, but I will give you a taste of what's going on and why it made so much noise. So basically, this web application here, it has a simple form that interacts with our backend written in Java. By entering some sample of input, whatever I want, and clicking the login button, I get this window, which is a window that we made just to hint that this information is being logged. Basically, if we are looking at the code of this application, we can see that the username was logged. Using the log4j, of course, logger. And it makes sense. Eventually, from developer perspective, it makes sense to log this data. And especially if we want to see some errors and we want to understand why a certain input from user caused certain errors, we might log it. Sounds like it might be a good idea, but actually this is what allows the exploitation of the log4j. I also pre-made an hacking environment for myself over here. I put it on other screen not to bother with this, but this hacking environment allows me to actually put a crafted payload that looks like this. Not going to dive too much on what is going on here, but trust me, when you put this payload and clicking login, what it actually causes is it's causing a spawning of a process on my computer. It spawned this calculator application. So let's see it just for a moment again. By putting this crafted payload and clicking login, you can see over here the taskbar of my computer that a calculator app was spawned on my computer. Now, the reason it's a calculator app is just because I configured my hacking environment to send a calculator exe command that will actually open this calculator just for you to see. But actually, I could craft whatever I want. I could run whatever command that I want, and it could be something very malicious like crypto miner. It could be ransomware. It could tackle and steal some sensitive data from my computer. So basically, just like this, remotely from just entering this server and entering this payload, I can execute whatever code that I want, and this is what actually makes it so dangerous and so severe.
Thank you, Guy. And of course, not all open source vulnerabilities are that dangerous. This is definitely once in a couple of few years example, but you can definitely find yourself with another critical or high severity vulnerability in your code. So let's see how it looks like behind the scene and inside IntelliJ IDE. And let's see a quick overview of the Checkmarx capabilities inside IntelliJ. So this is, of course, my IDE. This is the application we just showed you on the exploit demo. And as you can see, besides the code that I have here, I'm also using a POM XML file. During this demo, we'll show a POM XML file, but we also support Gradle files if you're using Gradle. And we're going to support some other stuff I'll mention later on. So for those of you who are not familiar, POM XML is the manifest file for my application. It does a lot of stuff related to build and a bunch of cool other stuff. But this is also where I introduce or declare the dependencies I use in this application. And this is where you can see the list of dependencies I use. And as you can see, some of them are highlighted. This highlight is the first feature that we have in the Checkmarx capabilities. Once I hover with my mouse, you can see the list of all the vulnerabilities related to this package. I can also right-click anywhere in the IDE, analyze, show vulnerable dependencies. I can, of course, use the keyboard shortcut, Alt-Enter, and I could click Show Vulnerabilities for this specific package. Once I click it or click other stuff that I'll show you in a minute, it will take you to the Dev Hub by Checkmarx, where you can see additional information about this vulnerability. I can also double-click the left shift and then just type Show Vulnerable Dependencies. Click it and it will pop the main tab for the dependency checker. As you can see, I have here a list of all the vulnerable dependencies I use. Once I click it, I see that again, log4j vulnerability or log4j vulnerability dependency is vulnerable. I can see a list of all the CVEs related to it. I can click report false positive. It will report it to us in case you think we missed something in this information. And again, you can also click read more. That will take you again to our Dev Hub, in which you can see more information about the vulnerability, and we'll get to that in a minute. One last thing, beside refreshing, you have here a green check that once you click it will show all the dependencies you're using. And as I mentioned before, some dependencies I declared explicitly, but some of them introduce more dependencies, right? So I have like 10 dependencies here. Some of them, as you can see, introduce more dependencies, and some of them even introduce, I'll show you here, introduce even more dependencies. And this is easily how I can scale from 10 to almost 30 dependencies only in this project. And obviously, some of them, as you can see in this example, could be vulnerable. So this is pretty much the high-level overview of the capabilities. And now let's see how you can leverage it in order to fix one. So Guy, take us through how to fix our first CVE.
Perfect. So in a moment, I will actually fix the vulnerability that we just saw. But before we do that, let's take a moment just to understand the process behind the detection of the vulnerabilities. So by clicking on certain vulnerabilities, I'll go to the POM XML again. By clicking on a certain vulnerability and hovering over it, over a package, by hovering over a package, I see the vulnerabilities inside of it. And then I can choose whatever I want to see. And by clicking on it, I will be redirected to the DevHub that Or just demonstrated. In this DevHub, we will be able to see much more information regarding the vulnerability. I can click on the Show More and get a much better grasp of the context of the vulnerability, why it happens, what are the prerequisites for it to be exploitable, and this might be a better help to get for decision regarding the issues that happened. The data that you see over here is verified manually by Checkmarx AppSec team. We collect information from various sources and discover some of our own, validating them to be precise as possible and mark the most accurate affected versions to have as less false positive as we can. And when you are, moreover, if you are already on the Dev Hub, you might be interested in looking at more free tools that we have regarding security and to upgrade your security knowledge and security tools that you are using. And let's go back to fixing the vulnerability. So when I'm here in my IDE looking at the POM XML, I can just put my cursor on the package, clicking the Alt-Enter on Windows, and will pop this window up. Clicking another enter will upgrade the version. If you saw, it upgraded from 14 to 17. And now all left to do is to synchronize the Maven, rebuild the project, and rerun it again. While we'll do this, I will show you another window, a dependency checker, that we can see in this dependency checker other vulnerabilities that we currently have and suggestions for those vulnerabilities. So you can see that I clicked on the cron teals and I see that the suggestion is to upgrade it to 9.16, to the version 9.16. Now, as we have our server compiled with the new version of the log4j, I'm able to demonstrate. Oops, sorry. I'm able to demonstrate. Let's refresh it. The application that we just saw. I will enter the malicious payload again, same payload as before. Sorry, and click it. I will close the calculator app that was pre-opened from before. Clicking the login with this payload will this time still redirect me to the next page, but this time we can see that no calc application was opened on my computer this time. Basically, that's it. We fixed the vulnerability. It was just a matter of a click.
Right, that's awesome, Guy. And it's really as easy as it can be in some cases. But in some cases, if it's the first time you're scanning your project, and if this project has been there for a while and you have some significant amount of code inside, it might not be as easy as possible, and you might have more than just one vulnerability in your repository. And as much as we, as the security side of the house, would like you and advise you to remediate and fix all your vulnerabilities, we do understand it might be a little bit of a challenge at the beginning. So we'll try to arm you with some more knowledge and some more capabilities on how you can triage and prioritize your vulnerabilities. So as much, as we're doing everything in development, you can start with small iteration and just keep improving it as you go. So the first way for you to prioritize is obviously by the severity, right? So we have inside the IDE here, you can see all those high, medium, low functionality that really shows you how critical the vulnerability is according with or alongside with CVSS score. As you can see, it's 9.0, 10.0, and so on and so forth. But in case you've been reached out by the AppSec team in your organization or the CISO, and they ask you for more information, or you want to get more context about the vulnerability and really understand, why it's such critical or high, or if it's really critical for you, you can see and get more information on the Dev Hub. So, Guy, let's take us through a quick breakdown of what a CVSS is and how we can use it to better understand the vulnerability.
Okay, so let's see, and let's break down the CVSS score of the log4j vulnerability, the one that we just saw. We can see that the score of the vulnerability is 10, and we are using this CVSS score that Or just mentioned. And what is a CVSS score? CVSS score is a structured metric of scoring. Is a structured scoring system, basically, which takes in consideration few features. Those features, we can see them, the breakdown of them over here. And let's focus on a few of them. The attack vector of this vulnerability is network. The attack complexity is low and privilege required are none. Basically, it means that the complexity of this vulnerability and the exploitation complexity is very low. It's easy to exploit. It requires non-privilege, so it doesn't require anything before, and it can be done over the network, so it can be done remotely. Combining this with the fact that this vulnerability allows executing whatever kind of code, whatever command the malicious actor wants, it makes it very dangerous, very severe, and this is why we got such a high score. So basically, this is the CVSS score. Addressing high vulnerabilities with high score makes sense due to these reasons, and going then and addressing medium and low vulnerabilities makes the sense to do next.
All right, so besides the high, medium, low version, we do want to offer two more ways to decide what you want to tackle first. I'll show you that in my IDE. One will be an exploitation. The second will be direct versus transitive. But I'll start with the exploitation part. As you probably know, vulnerability essentially might lay in some specific area in the package or in the dependency. Let's think, for example, about a database connector, right? Let's say my application needs a database and I'm using probably a database connector, which is open source, whether it's MySQL or other stuff. And let's just imagine that this library has only two functions. Let's say a read and a write. And let's say we have a SQL injection in the write function of that component. So let's just imagine I'm using in my project only the read function. I'm not using the write. So for that moment, this vulnerability, it is in my package, but I'm not exploitable by it, right? Or I cannot be exploited, or my app cannot be exploited by this vulnerability, right? Because it's in the other function. Now, while we do recommend to fix it, and let me just show you a quick capability currently in beta but we soon to have a GA on the IDE, what we call vulnerable path or exploitable path. For that, I'll just try to use this cron util package. I'll just create a new instance of cron parser. You'll have to excuse me that the code will not compile, but just for the sake of the demo. Once I call the method parse, as you can see, the minute I completely sent the writing it, it's highlighted. And again, if I hover it, it's the same highlight as you've seen in the POM.xml file. It says vulnerable API usage. Really means that I'm calling the vulnerable method of this specific vulnerability. This is, again, probably the most urgent thing you want to fix, right? So first, tackle the high vulnerabilities which are exploitable. Again, same thing, by the way, it applicable to the direct versus transitive. So for this example, right, if you get kind of the example of these functions, the vulnerable function, if it's in a transitive dependency, it could be a second-tier dependency or even a third or fourth degree dependency. If the vulnerability is there are less chances that the malicious input that someone probably injected from outside to your application will go through downstream all those function called to the fourth dependency or second dependency and so on. So it doesn't mean by any means we're not saying it cannot be exploited, but it is less likely and just more challenging to exploit. So we definitely recommend that you'll try to do those first. And by the way, you might not be vulnerable or exposed now, right? But let's just imagine, again, with the database example, I'm using just the read function. But next sprint, my teammate just now need to write something to the database and they will use this function. So again, try to remediate everything. But if you do need to prioritize, again, to summarize what we said, you can work with both the high, medium, low, and the severity or CVSS score mechanism. Use the exploitable function I just showed once it's available. But until then, you can just go and read it on the DevHub or other advisories to better understand where the vulnerability is and if it's relevant to you. And later on, of course, you have the direct versus transitive package. All right, so I think this is pretty much for today about open source vulnerabilities. But as we said, there are other open source risks that can be found or you can be exposed to by using dependencies.
So we'll briefly discuss a few of those risks. The first one that we will discuss would be licenses, which are legal risk, and the other one would be supply chain risks. So let's start with the license risks. It's important to understand that even though the code of certain software packages is publicly open, meaning open source, it doesn't mean that we can use that source code freely without hesitation. In the vast majority of cases, open source software is being distributed under certain legal licenses, sometimes even more than one. Those licenses describe the terms of the usage of the libraries, and licenses might differ. In fact, the open source initiative specifies more than 100 approved licenses. Some are more permissive, like the MIT license, but some present much more liabilities that should be taken in consideration, like an obligation to disclose the source of every software that is using the package, which might be impossible for certain organizations. So help yourself and take software licenses in consideration before you choose the library to use. Supply chain risks. Supply chain attacks is also a term that being heard a lot in the recent years due to the increasing trend of this type of attacks. Basically, it's important to understand that every component that takes part in the creation of the product, whether it's source code, third-party off-the-shelf product, or CI/CD tools, all those are part of the product and they should be treated like part of the product. Supply chain attacks differ from classic vulnerabilities in their origin nature. While vulnerabilities are being caused due to some bug or weaknesses in mechanisms that was used by developer unintentionally, supply chain attacks are executed by malicious actors that are trying to implant their code in your product. So let's dive into some of the common risks. So you can see here on the screen, maybe you are able to recognize some of those packages. If you did recognize them, I hope you noticed the typo on these packages, because the next attack that we are about to speak about is the package typo squatting. Package typo squatting is a type of software supply chain attack that happens when an attacker mimics the name of an existing package on public on public package repository in hope that the developers will download the malicious package instead of downloading the legitimate one. And it might cause a lot of harm. The next one would be dependency confusion. So let's talk about dependency confusion. This is an attack vector that relies on a flow that occurs due to the lack of usage of namespaces in the package repository. The technique involves an attacker who can determine an organization private package name. Then the attacker will publish the malicious package using the exact same name of the proprietary package with a newer version. Certain package managers and private repository configurations will cause the automatic fetch of the newer version between the private and the public repository, which eventually will cause you to get the malicious package again. So this is another type of attack. And we're going to discuss the malicious source code injection, which is a type of software supply chain attack. These attacks involve injection of malicious source code directly into the open source project repository. So in contrast to the two that we just talked about, that are about packages that were crafted by malicious actors, in this one, malicious actor inject malicious source code into the repository of the packages that you are already using. It is difficult and time-consuming to validate the legitimacy of the open source contributor due to the multiple open source contributors in the project, and this attack could happen in diverse ways. The example that you see over here in the screen is example of a protostware where the author of the package, the actual author of the package, pushed a malicious code into his own package. Other attacks might require account takeover before they are happening, when some account is being exposed and someone is mimicking it or using certain credentials to push malicious code into that repository. So to sum up, supply chain risks, packages that present supply chain risk malicious behavior are less likely to be found in your code. However, they present a very big deal because they contain code that was intentionally crafted in a malicious manner. So even just by installing those packages on your machine, there is already a risk of execution of the malicious code. So be careful installing packages, and soon JetBrains plugin would also be able to notify you upon the usage of those malicious packages.
All right, thank you, Guy. So we hope it was interesting for you. We definitely invite you to start to use these capabilities inside your IntelliJ IDE and try to fix some vulnerabilities or fix your first CVEs. So use open source, but use it wisely. And as we used to say, don't trust code from strangers. If you're interested in more security-related content, such as blog posts on open source licenses, how to use them, and what obligations or restrictions they can introduce to your code, or maybe some supply chain attacks or more advanced techniques, or even just a deep dive or technical deep dive into specific vulnerabilities, feel free to check our Checkmarx blog post. Or if you're interested in just getting more dev tools or DevSec tools that help you secure more part of your code, check the Dev Hub that we demoed. And last but not least, there are more to come from Checkmarx and JetBrains, starting with the next release of these capabilities inside PyCharm, ReSharper, followed by WebStorm, Rider, Space, and Quadana, and other tools by JetBrains. And of course, we will introduce, as we said, more functionality into the existing plugin. That would be the capability to ignore vulnerabilities that you're seeing, alert from supply chain attacks and malicious packages, and of course, the exploitable functions that I just showed. So thank you very much for listening today. If you find this content interesting, feel free to share it with your colleagues. As Mala said, like and subscribe. Thank you very much. And one big thank you for JetBrains for being such a great partner in this open source security journey. Mala, back to you.
Thank you so much, Guy and Or. That was a great presentation. And as I mentioned, our own security expert from JetBrains, Yaroslav, is already here, and he has been answering, he almost answered all the questions. So I have let's ask you some other questions. You also talked about malicious code in your presentation. So, is it fair to say that malicious package is more dangerous than vulnerability? Again, a tongue twister.
Yeah, so I think as we kind of said before, you can definitely get damaged by vulnerability, right? Especially with the example that we showed for Log4Shell. But as we said, you could have CVEs that inside your repository, and you might not be exposed to or cannot be exploited by, for the various reasons we showed. But as guys said, having a malicious package is something that is rare to happen. But once you have it, you're already being exposed and breached and so on. This is why we're really focused on providing this capability inside the IntelliJ IDE as soon as possible.
And before I ask the other questions, I want to remind the viewers that we have a poll in the comment section. So if you like today's session, don't miss to answer whether you like today's session or not. Now, moving on to the next question, or how can the developers avoid using a malicious package? Can they do
So
that,
yeah,
first of
and I
all?
think that I think that before or until you'll have this capability inside the IntelliJ IDE, what we definitely recommend is that before you introduce a new package in your repository, go and just Google it. Try to find by many great advisories out there. You can use our DevHub, you can use any other website or public advisory just to verify that your package is reliable, it's not known to any prior issues, or it's not malicious, it's not a type of squatting, it is what it is, and so on and so forth. Have someone from your team, a colleague, to review it before you put it. And again, we're going to be there soon to help you prevent it inside your IDE.
That's interesting. You also talked about upgrading the version so that developers can get rid of the issues with the security issues. But what happens if there is no safe version to upgrade to? What happens in that scenario?
So this thing it happens quite rarely, but happens. Some cases because of the maintainer just, stop maintaining the package, right? So it's some sort of abandoned package. There is no one to upgrade your version and so on and so forth. No one to fix it, no one to release a new fixed version. And in those cases, what we recommend in some areas, first you can go and try to switch the package to another one. It might be tedious, it might be some long work to replace all the function call you're using. Depends on how heavily you rely on that dependency. But you can definitely go and reach out in many cases if there is no official fix. Other security vendors, in some cases we also do it. We publish some sort of a workaround, bypass, mitigation, or other capabilities to keep that version inside your repository, but work around the vulnerability, maybe with proprietary code or other stuff.
And if I could say so, insurance and security are two things which people do not value much until they need them. So, a lot of times I see developers or other team members not being so much concerned about, let's say, a vulnerability which they think is not relevant to their project. So, how do they decide which, if they see that point in the IDE pop up? Should they go about fixing them? Should they take it as not relevant because of XYZ reasons? How would you answer that question?
So I think definitely what we showed in this demo today, try first to evaluate if it's relevant to you, or I would even start with, first fix it. It doesn't cost you anything, or it does cost you some time, but in most cases it pays off. Keep your dependencies upgraded. It will ease the pain later on if you need to upgrade it. Keep it as latest as possible. But as we said, you can always evaluate if this vulnerability is relevant to your code to see if you're exploited by it, meaning if you are calling the vulnerable method, or if you have reachability to this specific area in the component. You can also triage again by the high, medium, low. Low vulnerabilities can be exploited, but in some cases, it's harder to exploit and the impact is smaller. So we, as a security side or security expert, definitely recommend everyone to fix as many vulnerabilities as possible. But in case you're not really sure about it, there are many ways, as we said, that you can go and figure out if it's really relevant to you or not.
And I just want to say that a big part of the shift left trend is that we make these fixes much cheaper. The fact that we move them now to the IDE makes it much cheaper to and much easier. I mean, cheaper from effort point of view, much easier to upgrade the version and just see that it works. If you have the test locally on your computer, run your test right after you upgrade it, and you don't push this to a later. You don't make it a bigger problem when it's in your CI/CD already.
Absolutely. It makes sense to fix the issues early in the development stage rather than
Exactly.
fixing them quite late in the project. I remember one great analogy given by one of the thought leaders when I was listening to the session. And he mentioned that if he starts from his home and let's say he forgets his home keys at the workstation, how soon he would like to be reminded about that mistake, as soon as he steps out of the office or when he reaches his home. So that's what shifting security to left means. As soon as you identify and fix those issues, the better it is for your good. Now, I want to display one of the great comments, which is by Dawn, and he mentioned great information about OSS in general, and they would love to hear more from you talk about the OSS ecosystem. And there's another comment by the same person, not necessarily focused on vulnerabilities, but all the other issues that programmers, as I said, they're always in a hurry and try to put it off or either work on it later or not worry about doing that at all. Or and Guy, I would like to ask you another related question. So, what made you start working on this plugin? So, were there any specific issues that you were facing, which made you develop this plugin?
So I think while and first I'll just address the comment first. We'd love to,
Sure.
and hopefully, in the next few months, once we release more capabilities together, we can host more shared sessions about open source risk that not necessarily vulnerabilities. This was only the first in a long series, hopefully to come. But if you are interested, as we said, we have a lot of blog post records that you can go and read about licenses. We have a complete series about licenses, the implications, and what you can do about it. We do host our webinars for security experts on Checkmarx, and so on and so forth for the rest of the topics we have. So reach out, go and see our blog, and I'm sure you'll find a lot of interesting content there. And to your question, Mala, I think that, in our perspective in Checkmarx, we want to have security available to everyone, not only to our, enterprise and commercial customers. And when we were thinking about developers, we said, let's try to partner with, some software or development giants. And the first name comes in mind, was JetBrains. And we first reached to Yaroslav and his counterparts in JetBrains. And, we kind of started to talk about, the security issues and, how come that developers not always aware of it. And when they're aware of it, it might be too late and it being perceived in some cases as, the CISO issues and so on and so forth. And we really wanted to bridge this gap and provide these capabilities for free and for everyone. So this is really what kind of resonated and started discussion between us and JetBrains. And we're all, I think, very excited that, we managed to bring these capabilities for developers out there.
Right. And as I said in the beginning of the session, how you have been talking about or addressing those issues apart from your work, it really makes a lot of difference in how you bring solutions to any problem. Because I have seen developers who are working on a problem in their applications, but in parallel, they are doing a similar work in their physical world. So that really makes a lot of difference. The other, so again, another comment I want to highlight. So that's again by the same person. Great news about the upcoming feature. We have a thank you message. As I said, people loved the presentation. There was another one. Awesome talk again. So there's another thank you and very informative. There was another question. No, I think Yaroslav has already answered that questions. So let me, okay. So we have a lot of thank you messages now. See.
Sure, we're happy, and thank you everyone for listening. And again, thank you JetBrains for hosting us.
Pleasure to host this session. I really had a lot of fun hosting the session, as Alex always says when we start with our sessions, have fun. So I really had a lot of fun. Thank you so much for presenting, and thanks everyone who's watching, who is participating, asking questions. We really value your time. And before I end the show, I want to remind that next month we don't have another episode of IntelliJ IDEA live stream, but we are hosting IntelliJ IDEA Conf, which is a free and virtual online. Virtual is online conference for 2 days on 29th and 30th of September, where we would have sessions by industry leaders and experts. So please feel free to join, register, and we'd love to see you all there. Any closing remarks, Guy, and or if you would like to invite anyone to contribute to your project, or any closing remarks?
I just want to say, if we're speaking about contribution, that we already spoke about the DevHub a few times, but you can see on the DevOps few of our open source tools. They are, of course, they are free, and some of them are completely open source. So for those of you who are interested to see and learn more, you are more than welcome to investigate those, discover more, and learn. And you are more than welcome to contribute, of course.
Yeah.
So, I'm sorry.
No, I just want to say again, thank you, and use open source, use it wisely, stay secure, and hopefully to see you soon again.
Thank you so much. And
Thank you.
until next time, bye-bye.
Bye-bye.
Bye-bye.